ready to start our project. I've loaded into my Arduino IDE and I've named my file shmup.eno. Shmup is short for shoot 'em up. So what I'm going to do is the first thing I'm going to go in here to my library manager and just look up the U8G2 library. This is the one that we'll need in order to make our OLED do stuff. And let's install that. We'll see some stuff going down here. We've installed the library. Cool. Now we can close this and we can clear the terminal and drag it down a little bit. Okay. So we're going to start above the setup. In fact, we're going to do a lot above the setup. So I'm going to go to void setup and the front of it, if it lets me. Boop. And we're just going to press enter a few times. Maybe not that many. Okay. So up here, first things first, obviously we're going to include our libraries. So hashtag include. Let's do our U8G2 first. And then we're going to include wire. Alright, cool. That is our libraries imported. Easy peasy. We're going to use an object constructor to create our U8G2 library. Well, our U8G2 object that we're going to use. So we're going to say, in all caps, U8G2. So that's the name of the library. Then we're going to mention what OLED we have, or display. We have an SH1106. Its resolution is 128 by 64. It has no manufacturer name, it's just generic. And we're going to be risky. The Arduino Uno has, I think, like 2 kilobytes of memory. But we're going to take 1 kilobyte of that for this library. So we're going to say full memory. I want all the memory. And then some other stuff that I have no idea what that means, but this means right here that we're using the I2C protocol. We'll call it U8G2. And so inside this we're going to type U8G2 underscore R0. That just means that, hey, we're not rotating the screen. So it's going to pop up in the built-in generic landscape mode. And then we don't have a reset pin, so we're going to let it know that we don't have that. So we do U8X8 pin, all caps, none. Cool, and then we throw a semicolon after that. We're going to define a few things. So in C++, we can use the define keyword. And what that does is, well, let's write our first one and find out. So I'm going to say hashtag define joy x is A0. And there's no semicolon after this. So how does this compare to if I just did this? Well, first of all, int is a data type. So whenever the program looks at it, it's like, oh hey, it has a type, it's a variable, it takes up memory. What define does is whenever the program sees joy x, it immediately substitutes A0. It doesn't care if there's a type or not, it just says, hey, A0, and we know that because we're in Arduino, A0 is a pin. So when it sees joy x, it looks and says, no, that's A0. It doesn't store it as a type, it only stores it as A0. So that's a pretty nifty trick to try to squeeze memory out. Let's define a few more. We'll define our joy y as A1. And we'll define our fire button let's do all caps as 12. Alright, so Now we need to go ahead and throw some integers in here. These will be where the ship's located, what the position of the bullet is, and what the position of the asteroid is, and the asteroid speed. We'll also have a boolean for if the game is running, if the game is over, and if the bullet is active. So let's jump into it. Most integers are 16-bit. That's a lot. I don't want that. That also includes the signage. So what I'm thinking is we can cut down on the bit number and the signage to free up some more space because we are using the full buffer. So to adjust for that, we're going to use unsigned integers 8-bit. The drawback of that is the max value is 255, but that's not really that big of a problem. So because our screen size is 128 by 64, so for positions, we're not really going to run into a problem. So let's go ahead and write out our positions. So in order to get an unsigned integer of an 8-bit type, we just write uint for unsigned integer. It's 8-bit, and that's the type of it. And let's say ship x is equal to, I want to put it somewhere in the middle, so we're going to say 64 because it's 128. That's roughly half of 60. That's roughly half across the screen. We haven't accounted for the ship size, so it might be a little off, but it's okay. And then we're going to make ship y, and we'll set that one equal to 32. Same reason. And we're going to do the same thing for the bullet and the asteroid. We're kind of cheating here. What's happening is we're keeping the bullet off screen until we need it to be seen. So it's actually cheaper on memory to keep it off screen than it is to create it every time. So that's kind of fun. Okay, so here we set our asteroid x to 20 and our asteroid y to 0. That means that it appears at the top of the screen with the y, and initially it's at 20. The asteroid speed is something that we'll discuss later on, but for right now, what it's saying is the asteroid is going to move at a speed of 1, essentially. All right, so let's talk about the score. Our code, for now, is using unsigned 8-bit integers. That presents a problem when we get to the score. Say that somebody wants to play the game long enough, and they get past the max value of an unsigned 8-bit integer of 255. Well, what happens? The game probably crashes. Now, there's a very famous instance of this happening. It is the Pac-Man kill screen. If a player got to level 256, the game became corrupted because it used a single byte to store level information, and a single byte can only go from 0 to 255. So when the player loaded into 256, it couldn't. Like the program couldn't run it, so it wrapped back to 0. And that caused the infamous Pac-Man kill screen. So what we're going to do is we're going to not do that, and we're just going to use an integer. So int score is equal to 0. Cool. Alright, and then we're going to reference that, not like a memory reference. So we're going to set some things up to use that ITOA that we talked about in the hand-drawn part of this video, where I said integer to ASCII. What we're going to do is we're going to set up two arrays. One is going to be a character array called score text, and the other is going to be a character array called game over. We're going to say char score text, and I want to capitalize, there we go. And we want this to be 12. And then char game over, we want it to be 20. There we go. All right, now let's set up our booleans. So the first boolean we have is to see if the bullet is active. So we'll say bullet active, and we're going to set it to false because we don't want the bullet to be active right off the bat. We only want it to be active whenever the player makes it active. Then we want our game, we want it to be true. This is going to make sure that the game is actually running. And conversely, we're going to have one called bool game over. And we're going to set it equal to false because if the game is true, game over is false. Right. And then we're going to have one last one. I want the player to be able to play a new run after dying. So we're going to have some time, and during that time, the game over screen will be displayed, and then it will reset. So we're going to use an unsigned long for that. This is going to take up some memory, but it's okay. Did I spell that wrong? I did. Okay. Syntactical coloring, syntactical highlighting. So I'm going to use an unsigned long, and I'm going to call it game over time. And we'll set it initially to 0 because if the player hasn't lost, then the player hasn't lost. All right. Now I want to make my ship, and I want to store it in program memory. Two types of memory. We have SRAM, which is where integers, ints, and other variables are stored, and that's roughly 2 kilobytes. However, we also have flash mem. That is 32 kilobytes. So if we store something in progmem or program memory, it's being stored right here in flash memory. And that's exactly what we want. Now our ship is only going to be like 8 bytes. It's not that big, but it is good practice. And we're going to use a bitmap. We're going to say static. And the reason why we're using static is because normally variables are created and destroyed within a function. Static lets the compiler and the Arduino know that, hey, this stays. This doesn't go anywhere. Then we're going to say constant, which means it can't be changed. It's unsigned. And it's a character array. And we're going to call it ship. We'll set it empty. And we're going to dedicate it to program memory, like how we just talked about. And let's go ahead and make it. So with a bitmap, it's pretty straightforward. You use bytes, and then where you want nothing to appear, you put a 0. Where you want something to appear, you put a 1. You have to have a header, and that header is 0b, and that lets the compiler, interpreter, what have you, know that you're looking at binary data. So we have 0, 0, 0, 1, 1, 0, 0, 0. All right, so there's that. And I just want to be fully clear, I do have the code pulled up on another monitor, and I'm copying off of it as I type. So I'm not just pulling this out of my butt. And that's why some things are slow to type, because I'm a bad typist. So that is our pre-setup setup, just declaring stuff. So now let's go into our setup. First I'm going to go down here and press enter a few times. There we go. All right. So in the setup, all we're going to do is define some pins, or define a pin, and begin our U8G2. To define a pin, it's really easy. Just do pin mode. And we're going to say the fire button. I'm going to make sure I'm typing that right. Yep. It is going to be, we're gonna use the internal pull-up resistor. Just see if we can cancel some noise if there's any. And then we're just going to call our U8G2 library and tell it to begin. And that's it. That's all there is to the actual setup. Now comes the fun part. I'm going to check to see if the game is over first, because if it is, I want to stop the loop immediately. And if it isn't, then hey, keep playing the game. We're just going to use if, and let's see, called it game over. Let's go change that. I'm not a big fan of Pascal case, so we're going to change that to a lowercase g. There we go. So if the game is over, first things first, we're going to clear whatever's on the screen. So to do that, we use a U8G2 command called clear buffer, or function, I guess, method, what have you. And then we're going to draw something. To draw text, first you have to select a font. And we're going to set the font to a built-in U8G2 font. Let's see. There we go. Don't ask me what it means, I have no idea. I just know that this is a built-in font from the U8G2 library. We're going to say U8G2 dot draw string. String is capitalized. And I just realized that we have a problem. Up here on line 24, I have, well, first of all, there's a typo. I have game over, but then I have game over right here as a boolean. So let's go ahead and change this again. We'll say is game over. There we go. Nice. And now what we're doing here is we are actually drawing whatever we decide to put inside this character array. Right now the character array is empty. That's okay, we're going to take care of that later on. Alright, and we're just going to send all of this. Alright, so then inside this if statement, we're going to run another if statement to kind of reset the game. So we're going to say if a certain time if the internal clock has determined that game over time is greater than 3000, then, or 3 seconds, if you will, then we're just going to reset our game. And we're not going to write a special function to do that. We're just going to code it all here. We'll set our score back to 0. We'll set our ship X back to 64. We'll set our ship Y back to 32. And we're just going to make our asteroid appear on the x-axis at a random value of between 0 and 128. If I can spell, that would be great. Boop. There we go. But essentially, if more than 3 seconds has passed, our score resets to 0, our ship resets to 64 and 32, our asteroid resets to a random position on the x-axis, and then 0 on the y-axis. We may change this later on based on how that interacts with our score text, but And then we set our bullet active to false, game over is no longer true, and our game is true. And after all that, we exit this by entering a return, and that is the game over loop. I want to see if the game is active. What this is going to do is it's going to allow me to move and control the character. So if game, and instead of using joyx and joy, I want to save them to a variable that I can then put in. So we're going to say int x value is equal to analog read, because that is what we're doing. We're reading the analog of joy x, and then we're going to say int yval is equal to analog read joy y. Now, why are we saving this to a variable whenever up here we decide to define it? Well, I'm glad you asked. So, joy x, we define it as the pin A0, and joy y is the pin A1. So right now, these are the only values there, A0 and A1. What we do here is we look at the recorded value from those pins. So this isn't the same thing as joyx, is the value from joyx, and this isn't the same as joy y, it's the value from joy y. So it cut down like 2 variables, which was fun. Alright, so now let's do our collisions. We described the collisions earlier in the game. Oh, shit. Now let's do our movement. The movement's really easy, it's just a bunch of if statements. So I'm just going to speed through those. Okay, so we just have some simple movement right here. And then here we have some wraparound features. So hopefully, if the ship is greater than 128, it will appear at the X, so it wraps around the screen. We'll see if that works or not. All right, on to the next thing. So let's check to see if the button was fired. So up here on line 46, our fire button is pulled up. So that means this resistor is pulled up. It's technically reading on high. So we want to check to see if it's reading on low whenever we fire it, because whenever we fire it, it should read as low whenever we press the button. So we're going to say if digital read fire button, if that's equal to low and bullet active is false, then we're going to do some code. So the first thing we're going to do is set bullet active to true. And then we're just going to set the bullet. So that just reads and checks to see if the button was pressed. Now if it was pressed, it sets the bullet to true. So let's see what happens whenever the bullet is active. So here we just check to see, is the bullet active? If it is, it moves up the screen at a rate of 4. And if it goes off the screen, so y is less than or equal to 0, the bullet is no longer active. So now let's go ahead and see if the bullet collides with the asteroid. So to do that, like before, we're going to use the absolute value. So we have to make sure that the bullet is active. So if bullet active and those absolute values we talked about. So is the bullet active, and is the bullet in collision with the asteroid? If it is, we want to set bullet active to false, because we want to disable it immediately. We want the score to increase by 1. And then we want the asteroid to go back to a random x position. Let's change our asteroid y to 12. So I'm going to go up here and do that as well. That way it keeps it below the score. There we go. Fix the missing semicolon while I was there. So that way it keeps it below where the score is going to be. Okay. So that checks to see if the asteroid is in collision. And then let's see if the asteroid is in collision with the ship. We want the score to decrease by 5. Alright, now let's handle our game over. Game over is going to be based on our score. So if the score is less than 0, meaning the players lost more than they gained, we're going to set game over to true, and we're going to set game to false. And we're going to use a function called string copy, and what it does is it's going to copy a string into our character array. strcpy. Our character array is called game over. That is this guy right here. And the string I want to copy is game over. All right. And then we're going to set our game over time to a certain number of milliseconds. I want this to check every time the ship is struck by an asteroid. So what I'm going to do is I'm actually going to take this curly brace on line 104, and I'm going to scoot it down to line 112. And let's press enter a few times. And we'll indent this fella. There we go. And we'll indent. Nah, that's fine. The check to see if the score is less than 0 happens every time the ship is struck by an asteroid now. All right. We're almost done. We only have about 20 more lines of code to go. Yeehaw, all right. Let's go ahead and set our asteroid speed. Now the asteroid, it's moving in a y direction. So we're going to increment the asteroid y by the speed. Did I spell that right? We'll find out. Asteroid y plus equals the asteroid speed. That just means for every frame it moves the speed of the asteroid, which we set to 1. What happens if the asteroid goes off the screen? Because we're in the y direction and the y has a max height of 64, we can just check to see if asteroid y is greater than 64. And if it is, we just reset the asteroid. So I'm going to set the asteroid y to 12. and the asteroid X to a random between 0 and 128. Alright, and that is the game logic just about done. Now all we have to do is draw the stuff to the screen. So this is where the UHG2 library comes in, and we will use the built-in functions and an if statement in order to draw all this stuff. I'm just going to type it out, and then we'll talk about what it means later on. On this line, all we're doing is we're clearing whatever may be in the memory buffer. So we're clearing it out so we can send new stuff. We set the font, we set the score. This thing just says, hey, print this screen right here at these coordinates of 0 and 12. And then we set score text. While I was typing this, I realized that we didn't do the thing we needed to do, so we'll go back and do that to get the score text to actually show up, which is the ITOA that we talked about. And then we draw the bitmap of the ship X and the ship Y. We say that it's an 8x8, and its name is ship. If the button is active, or the bullet is active, we draw the bullet, and we draw the asteroids as a disk at asteroid X and asteroid Y for the coordinates, and they have a radius of 3, and then we ship it all out to the processor, and it displays it. And then we just delay for 20 milliseconds. Let's take care of this, because if we try to load it right now, it'll be like, hey, score text doesn't work, what you doing? In the code that I have pulled up that I'm working from, I have it right here. After we check to see if the game is over, we're also going to take the score and just change it to something that UHG2 can read. So we're going to say ITOA. Remember, that's integer to ASCII. We want score, which is our integer. We want to store it in score text, and it is a base 10 integer. And that's it. I believe as we type, oh, I don't know why I put it there. There we go. I believe as we type, it gave us a doc string. Yeah, there we go. Cool. That should do it. I'm going to compile this and send it to the Arduino, and I'll see y'all on the other side. Well, the non-digital side, I guess the non-IDE side. Anywho, toodles.